today's topic, guys, let's talk about the hydrocarbons. So hydrocarbons can be subdivided into saturated and unsaturated hydrocarbons. So what are the hydrocarbons and the hydrocarbon derivatives? So a hydrocarbon is a compound that contains only carbon atoms and hydrogen atoms. That's why hydrocarbon, because only one carbon atom and hydrogen atom. Thousands of hydrocarbons are known. So a hydrocarbon derivative is a compound that contains carbon and hydrogen and one or more additional elements such as your oxygen, nitrogen. So additional elements commonly found in hydrocarbon derivatives include your oxygen, nitrogen, sulfur, phosphorus, so chloride, bromide, and millions of hydrocarbon derivatives are known. So these are your organic compounds. Then they can be subdivided, hydrocarbon derivatives. In our hydrocarbons, we have the saturated hydrocarbons and the unsaturated hydrocarbons. When we say saturated hydrocarbons in which all carbon-to-carbon bonds are single bonds. And then, for our unsaturated hydrocarbons containing one or more carbon-to-carbon multiple bonds. Meaning, kung saturated, single, unsaturated, multiple bonds. So, hydrocarbons may be divided into large classes, the saturated and unsaturated. A saturated hydrocarbon is a hydrocarbon in which all carbon atoms are single bonds, meaning there is a single bond sa tanan ni mga carbon to carbon ni mga bonding. Later we will see an example of this. Saturated hydrocarbons are the simplest type of organic compounds. Since they are forming only single bonds, so they are the simplest form of organic compound. An unsaturated hydrocarbon is a hydrocarbon in which one or more carbon-to-carbon multiple bonds. They have the double bonds, triple bonds, or both are present. In general, saturated and unsaturated hydrocarbons undergo distinctly different chemical reaction. So, two categories of saturated hydrocarbons exist. Those with acyclic carbon atom arrangement and those with cyclic carbon atom arrangement. The term acyclic meaning not cyclic, meaning hindi siya in circle formation. No? And then, the following notations, but it is still, saturated hydrocarbons, it's because ang carbon to carbon niya, tanan, single bond lang ang naga-attach. And then, we have, for our cyclic, this one is an example. So, even though cyclic siya, but all the bonds are still single. So, one example of our acyclic saturated hydrocarbons is we have the alkanes. An alkane is a saturated hydrocarbon in which the carbon atom arrangement is acyclic. Thus, an alkane is a hydrocarbon that contains only one carbon-to-carbon single bond saturated and has no rings of carbon atoms, meaning acyclic ang aton alkanes. So, alkanes are, kumbaga pa, these are the family name or general term. Later on, makita din natin na may mga different kita nga mga alkanes. So, the molecular formulas of all alkanes fit the general formula of CN and corresponds to the unknown na number of our carbon, H2 and 2. So, ang general nga formula for our alkanes, where N is the number of carbon atoms present. The number of hydrogen atoms present in an alkane is always twice the number of carbon atoms plus 2 more, as in, for example, so aton tanan nga alkanes, ang iya nga usual nga ang iya usual nga chemical formula is CN, H2, and 2. It's because kung pila ang aton nga ang atoms present in our carbon, twice the number ang makita natin sa hydrogen. So, for example, if we have the C4H10, so 4 carbon atoms, so for our hydrogen, i-times 2 mo siya, that would be 8 plus 2. That's why it's C4H10. Also, sa aton nga C5, 5 carbon atoms for our carbon, and then, ang sa aton hydrogen naman, it should be times 2 isang atoms nga present sa carbon, which is 5. So, 5 times 2 is equals to 10 plus 2 because that is the general nga formula for our alkenes and so on sa mga example natin. So, the structural formulas, the three simplest alkanes are the methane, which is the CH4, the ethane, C2H6, and propane, which is the C3H8. So, three different methods for showing the three-dimensional structure of the simplest of all alkanes are given. So, this is for our methane, so all single bond, and it contains 4 hydrogen na mga atoms. And then, for our ethane, single bond, C2H6. Ay, ara nga, tatlo ka-hydrogen. Since our carbon atoms can only bond 4 lang now because 4 lang ang available na atoms for bonding. So, we have tatlo ka-hydrogen for the carbon sa piyak, the same also sa piyak. Then, we have the propane. The propane, we have the C3H8. So, C, carbonaton, tatlo. And then, for our hydrogen, it's 8. 1, 2, 3, 4, 5, 6, 7, 8. So, ang iya ball and stick models, kung tanahon naton, and space filling models. So, two-dimensional structural representation for organic molecules are called structural formulas. Kung two-dimensional ang structure, that is called structural formula. A structural formula is a two-dimensional structural representation that shows how the various atoms in a molecule are bonded to each other. So, saturated hydrocarbons, our example, ang alkanes nga family, simplest member of the hydrocarbon family, contain only hydrogen and carbon, only have single bonds. All members of the general formula, CnH2n plus 2. So, twice as many hydrogen as carbon plus 2. So, this one, yeah, for example, the C5, so kung 5 ka-atoms ang present sa atom nga carbon, so dapat twice sa atom nga hydrogen, so 2 times 5, that would be 10 plus 2. So, C5H12. Then, for this one also. So, saturated meaning single. S, remember. So, for our prefixes, sa mga alkanes natin, you have the meth for 1 carbon atom only, eth for 2, prop for 3, bute for 4, pent for 5, hex 6, hep 7, oct 8, non 9, and dec 10. So, just like sa aton nga pentagons. So, CH4 methane because alkane. So, tanan nga alkanes ending in also methane, ethane, propane, butane, pentane. So, their boiling point, melting point, and density. Please familiarize this one as this will come out in our exam. So, naming organic compounds. So, there are different kinds of naming of organic compounds, and one is according to the IUPAC system, or the International Union of Pure and Applied Chemistry System of Nomenclature. So, alkanes and in, alkenes and in, and alkynes and in Y and E. So, later, we will also talk about the alkenes and the alkynes so that you can be familiar with that one.